So 5.1 was a bit of an exploratory exercise, and if you went through it, you'll have gotten to where we're at right now at 5.2 in the Get Started. Exponential functions don't mean x to the power of an exponent. They mean a number to the power of x, so that x is the exponent. And there's a couple of things that you will have noticed by now as our basic equation and our basic graph. If y equals some number to the power of x, and that number is greater than 1, obviously if it was just 1, it would be a straight line at 1, so 1's no fun. But if it's greater than 1, then we'll have this gradual curve up like that from left to right. If our base is actually a decimal, so between 0 and 1, then we will have a descending line that goes like that. So those are our basic, it's a mirror image of each other, that's our basic shape. We've got some anchor points that we need to be aware of, so that's what we're going to look at now. Our horizontal asymptote, you'll see that these lines are approaching 0, but they never actually touch them. That's because it's a horizontal asymptote. So we have a horizontal asymptote at y equals 0. It's never going to touch 0. Y will never be 0. And you can play with your math to figure out why that is. The y-intercept, right here and right there, is 1. So you'll have a point at 0 and 1. The reason for that being, it doesn't matter what your base is. If you have something to the power of 0, the answer will always be 1. Anything to the power of 0 is 1, whether it's a decimal or a whole number. So that's why we have a y-intercept at 0 and 1. Now the domain for these things, you can see on the x-axis, they just keep on going. Sure, they start getting steeper, but they're still going to keep on going. You'll always be able to plug in any x value and get a y answer. So our domain for these is always going to be x is in the realm of all real numbers. Now the range is a little bit different because obviously we've got, for these basic equations, we've got a limit to y, 0. Y will never be 0. Not equals and is greater than 0, but just y is greater than 0. So that's going to be our range for all of these functions. Now the next thing that we're going to do is apply a method to changing the patterns, moving them around, doing the same thing that we did back in chapter 3. But what we need to understand is that every exponential equation has a basic pattern like this, and the only thing that's going to change it from one equation to the other is actually what the base is. Now to get the specific graph for any of these equations, we're going to need to put in y equals the base that they gave you, like 3 or 2 or whatever, to the power of x. And then you'll get your table of values, which you should be able to get from your graphing calculator. If you don't know how to go between the graph and the table of values, let me know and I'll explain that to you in a different video. Once we've got this basic establishment and we know that we can go to our graphing calculator and plug in y equals the specific base to the power of x to get our basic pattern, then we can continue on to the part where they give us the formula that shows us the transformations and the all the other fun stuff that we get to do.